Hi, and welcome. Nicolai Josuttis is today our interview partner for the interviews and conversations about Meeting Supervisors 2024 and the trainings. So, welcome, Nico. How is it going?
Hi Jens, good morning. Yeah, welcome. And all is good. A lot of traveling, a lot of trainings. This is high season. Autumn is always high season when you give trainings.
Yeah, that's true. I've heard you just came from CPPCon.
Yeah, well, long time ago, 2 weeks or so.
Okay.
Yeah.
How was it?
I liked it. Numbering are getting better after Corona.
Hmm?
You see that. It looks a little bit like a new generation is coming to CPPCon. So I'm
Okay.
not sure that it looks a little bit like we lost a couple of people in Corona. So I don't know why, but now a new generation is coming. A lot of young, interested people. That's nice. Good.
That's great to hear. Actually, Meeting Supervisors also has a student program, so we will have some young people on the conference too, um, and online because we're hybrid. Um, let's get started the interview. Just what have you been up to with C++ recently? What's something you have on your mind?
Well, you know that I'm part of the C++ committee for more than 25 years now, and that means I'm part of this big path that is really long now. This big journey, I would say. Um, there are a couple of things that are that are currently well making me a little bit thinking about things. So that is, for example, I think the entropy of C++ is still rising, and we are getting in critical situations now with this programming language. And the other thing that on the other hand, as usual, we have new stuff. And then third, when I start to describe this stuff, so for example, the last big book was about C++20, then we found flaws and we found interesting things. And um, I'm currently not so happy about what we standardized. I think we have to do better. Yeah, let me say it that way.
Yeah, the ongoing standardization is always interesting. Um,
I'm part of it, so it's also my fault.
I think that you're the good part of the committee. And actually, like something which has been standardized with C++20 is concepts, and that's something you speak about at the conference. Um, what can we expect from your talk?
It was a little bit funny at CPPCon. I already gave this and talked about that under the idea of back to basics. So it seems concepts just established in C++20 is now a back to basics talk. So we have new basics here, and that's really brand new basics. Um, to be honest, I thought that's appropriate. I thought that is really a new thing that helps us tremendously to formulate and deal with generic code. And it's very compelling. It works really great, I think. And you need a proper introduction because you have to explain about granularity of concepts, etc. But it is really a big, 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 very important thing for the future of C++. Yeah, so it was, yeah, and I will talk about just the basics, of course, introducing concepts, talking a little bit how about the granularity of concepts. Something that is very important is how to deal with them in practice. So one is, for example, how do you test concepts and why do we have to test them? And then, of course, talking a little bit about the different flavors of concepts. For example, concepts can not only have functional aspects, or I should say compile time aspects, they formulate requirements on generic code, but requirements can also be non-functional or runtime requirements, and how to deal with that is also important to know. So there's a lot to tell. With the example of C++20 ranges, where we most of the time use concepts, and also explain why we don't apply these concepts to standard algorithms. We have to apply them to ranges algorithms. And yeah, there's a lot to say. So I don't know, 1 hour, I think, is a talk, is full of slides.
Yes, and this will be in the main track, so this will have for sure a big audience.
Good.
While we're at concepts, I saw that actually I organized trainings after the conference, and one of the trainings that is given with you is like a one-day training on concepts, ranges, and views. And so maybe we should talk a bit about like how concepts, ranges, and views are connected and then form this new way.
So concepts, ranges, and views. So concepts describe a way to formulate requirements. These requirements can be applied to any generic code. At the same time, we standardized a ranges library, which makes it easier to deal with ranges, especially coming a little bit over the general idea that we always specify begin and end when we have to deal with ranges, but now to deal with ranges as a whole, as one argument, as one parameter. And to be able to have good error messages or right behavior, we use in this ranges library concepts. At the same time, concepts benefit from a big application of some standard concepts in ranges. So we learned about which rules work with concepts, and we also saw what should be used as standard concepts, and so the granularity about them, and so on. And views then on top is a way to create a view on a range, which is double checked with concepts. And in this view, we can then formulate pipelines. Looks a little bit like Unix pipelines when you're on the command line can create pipes of single components, creating massive, interesting effects. However, the approach here is totally different. And that's also one thing to learn. And it has tremendous consequences. For example, just filtering elements in a range that's not the way you think it should. So you have to learn something about it before you use it. Or you will learn it the hard way. Or you don't see that you have undefined behavior. So things like that can happen.
True. And the day before, you're giving a training on generic programming in C++ with templates and auto, which is a bit like leading into concepts, I guess, when you need to learn about generic programming first.
Yeah, that's interesting. I mean, we have written with a couple of co-authors, David van der Voorde, and especially we have written a book about templates and generic programming. That has 850 pages, just generic programming in C++. So that's a huge topic. It's probably the key big programming paradigm that made C++ a success story. And concepts are just one aspect now, saying we can formulate requirements to make proper decisions when we have overload resolution or to improve error handling. And so here we talk about the basics. And the basics is not just a function template or a class template, which is just at the beginning of this class. Let's go into more details about non-type template parameters, about variadic templates, fold expressions. Let's talk about can you use a lambda as a template parameter? Let's use about sphinx. Some people might have heard that. And what is that about? So there's a lot to tell about generic programming, definitely more than one day. I will select in this training the most important and stuff for generic programming. An application programmer should know.
That's true. Generic programming is really big on C++, and then concepts is just adding on top of it. And I remember you speaking on views last year, and also prior to that giving a keynote where you pointed out some shortcomings in the ranges and views area. As your committee member, how much of this has been addressed or could be addressed? How was the reaction to those talks, and what could the committee do about this?
In principle, others should decide about how this works and what the effect of this is. All I can say is I'm usually look into new features of C++ with the eyes of an ordinary programmer. I'm not that smart. Other people invent new features of C++, but I try to understand them and then to explain them to others. And there you sometimes see that it's hard to teach that, or it's something is non-intuitive. And we have, I think, in the views area, not in the ranges area, in the views area, made a couple of really bad design decisions. I started to criticize that, and that's not fun. If you work on that with 10 people for 3 years, then it's not fun to hear, well, this might not be appropriate. So the usual reaction was, no, maybe, Nico, you didn't get it, and maybe you should teach it right. But I taught it right now a couple of times. I explained why we have the current design, and then I think after a couple of years now, I can pretty exactly formulate 2 things. First of all, our design decisions are not appropriate because the design decisions we made on views were allowing programming by compromising established patterns in C++. For example, just a simple example, views have the ability that the check for empty is no longer stateless. So checking for empty can change the behavior of your program. That's totally confusing. And that is a runtime problem. That's not a compile time problem. I think this is really bad design, especially as we now in C++ more and more have to care for safe programming. We say that in the language, but we don't do that. So we fall into our own traps, being experts. We say, yeah, we understand everything, and we want to have this little nice feature, and we don't see that we compromise existing basic features. And I think that's a problem that I've never seen so crystal clear as in views. So it's all about design decisions. Everything is documented, but we have to get rid of runtime errors and unexpected behavior for ordinary programmers. Unexpected behavior should be something for experts, and undefined behavior, the same. So I think we have to change that. It looks a little bit like the first members of the ranges subgroup start to understand that my command is okay. It took me 10 years to fix the range-based for loop. And so maybe we need less time here, especially as I last week learned that what I complained about is something we seem to have done in Rust correctly. So, and your argument that might help to come to work on this, yeah.
Yeah, it's so you think that is fixable? It's not like that. I know there's so many design issues, and I think you also were related with LockGuard, that we have like multiple LockGuards because we cannot break ABI, and
I fixed atomics. I'm the fixer. So Well, it happens. I'm as a book author, you are an early adopter of this programming language. You find early things and then you complain. And the other thing, as a teacher, you see what works good and what works bad. And STD thread is another type I fix, and we came up with STDJ thread because of that. So yeah, and I think views have to be fixed. They have to, definitely. Otherwise, too many projects already tell me, no, they will ban it from the use. And it's a great concept, but we have to fix a few design decisions. That's the point.
Yeah, I think it's a really interesting time to see how C++ evolves and what errors made in the...
And you asked me, can we fix that? I think we can fix that. So I discussed it now with a couple of people and said, no, we can fix this in a way that we break only some more or less esoteric use cases. So definitely not trivial use cases. And we would not change existing runtime features. We would no longer compile a few examples, but we would increase the safetiness and the predictability of this whole view library significantly. And I discussed it already with a couple of people, and I'm pretty confident now that we have the right approach how to fix this. And the first thing we have to fix is the filter view, because filtering is your day-to-day bread. So you want to have a very simple, just working option to say, let's filter the elements of a collection in some way to read the elements or to process them or to even modify them. And that currently is not possible. That's one problem.
Okay. So we're currently in the flight for C++ 26, and the committee meeting will be after the conference. Do you have any papers in flight for this or other things?
Yeah, a paper is in flight. I have it in flight for 2 years now. I hope it will be done now. And the paper title will be Healing the Filter View. Okay. When it is published, I plan to publish either this paper more broadly on Reddit, etc., because it will be written in a way that ordinary programmers can understand what the problem is and how we could fix that. But I might also come up with a paper with this slightly similar, saying Taming the Filter View, which is the title of the talk I gave at CPPCon, and which just describes the problem and how to deal with that without fixing the standard. So what does it mean in practice to deal with that? So it's 80% of these two papers would be the same. It's just in one paper we say, how do you deal with that? And in the other paper you say, how can we fix that? And the step. So, and yeah, I'm definitely planning to write that. And it's already on the way. It's just my time is limited.
It takes time, yes.
Yeah, as usual.
Standardization is always a long-time project.
Yeah.
So speaking about C++ 26, it was like the big topic from keynotes. What one was, see from CPPCon if one wasn't there. So what does get you excited for the next standard?
That's a little bit funny. I'm starting to get excited. And one topic that really will change a lot is reflection, definitely. We will, with reflection, be able to do a lot of things, including this little piece of the general answer I have to give in each and every training. Why is there no standard way to create a string from an enum value? And for almost 20 years now, we say, oh, wait, we just need reflection and it will come. And maybe we finally have it there. And but that's only a very small thing. Herb Sutter in his keynote showed a couple of interesting examples. And yeah, a lot of things will change with that. I'm not aware of many other huge topics that come, as usual, some smaller, and we care a little bit more about safety. My problem is a little bit, I'm really a little bit behind. So writing and caring about C++20 took a lot of time. And we have the problem that we have 200 people standardizing C++, and somebody has to document that, as there are not many authors describing the stuff. And I have this role to some extent in this community. I have to understand all these topics, and including pitfalls, and that takes some time. So I'm still struggling, and just started with the C++23 book. And then I might then, when I have that on the way, start with C++26 topics. Although, of course, in the standards meeting we talk about
it's early to start a book on 26. That's like, I mean, I've last weekend looked up what one gets when you update to GCC 14, and I was like, on the one hand, fascinated how many C++26 features are like green on the graph there. But when you look closer, it's like mostly low-hanging fruit. Like, we corrected this, and you cannot do this correctly, or we do this now in this detail differently. But the big features are still in flight, or some coming in 15, and 23 now being more complete with support for deducing this in GCC 14, which wasn't supported in GCC 13, which I think is interesting because it's a great feature of 23, definitely. And I see many people having big hopes for reflection, pattern matching, executors, and maybe networking.
That's a funny story, Jens, which is I think 2 or 3 weeks ago, I did the usual training, and I talked a little bit about the fix of the range-based for loop we did in C++23, and which was on the right-hand side of the range-based for loop. You have a problem if there's a reference to a temporary, and then we tried it out with compilers, and all 3 compilers did not handle it correctly yet, the latest trucks. So that's a little bit funny that one of the key fixes we have in C++23 is still not in the compilers. But we have a lot to try out with C++26. I'm not sure I like that. To be fair, Clang has implemented that. But they still give a warning, which is now useless because it's fixed. And GCC and Visual C++ didn't have fixed it. Yeah, and but by the way, that's always fun. So I asked in the standard committee about what's the state of this. Did I get a problem wrong also? In the end, yes, it takes some time to implement things. Of course, it's good. Sure. It's great. They do the good job, these developers of compilers. And then they've also patched already, and they said, oh yeah, maybe we should do it now in GCC. So I heard that this key, I think, little but key C++23 feature is now fixed in GCC 14 or 15, so the next version, which I think is a little bit late. But okay, so we have a general problem, I think, and the general problem in C++ is we standardize too much. For sure. It's hard to write about it. It's hard to keep track of the different changes. It's hard to update compilers and libraries for that. It's hard to understand the consequences of a change. And this cannot go on. I think this is an absolute nightmare. And especially as the libraries we standardize now are very, very often not standardizing existing practice. They standardize something brand new. And then we say, yeah, but we have to be backward compatible when we learn there's something wrong. And so that's not a way we can continue to work. I think that, and that was never the idea of an ISO standard. An ISO standard has to say we standardize existing practice. Yes, I've also proposed things that were more or less designed on scratch, from scratch. And for language features, to some extent, you have to do so.
Yeah.
But the speed we have now comes up with, some nightmares, which would never happen if we wait until things are established in the community, especially for library. Well, yes, for library features. For language features, it's a little bit more tricky to do that, for sure. So
Sure.
I'm not happy. I said at the beginning, the entropy of C++ is growing, and we're coming to a critical situation, I think.
Yeah, I remember years ago there was a paper which wanted to add like interfaces and ways to say this part of the code is only valid in the new standard, and then you can fix the ABI for that standard, and the old standard still keeps the old ABI. But that didn't go very far, I think.
There were a couple of proposals to say, let's have more smoothly come up with new features. And it also covers a problem that we have to deal with: when and how can we break backward compatibility and maybe smoothly over 3 versions. That was a major complaint that came partially from very big companies and said, we have to fix that. We have to come up with a process where this works. We were not able to do so. And as a consequence, we are seeing now more and more programming languages that are the next generation programming languages following C++. So Rust, of course, is currently interesting in its maturity. It's getting interesting, I think. And we have other things on the horizon, which at least created some trouble just because of an announcement. And especially if Google is behind, of course. And then, so I would be a little bit careful. I'm too old and have seen too often some hype about some new stuff, and then 10 years later, nobody's talking about that anymore. Which could also happen with Rust, but it could also happen with new C++ features, like modules. Modules, in general, a great idea, but some homework was not done right. And so
this was the most popular talk for this year in the voting. Getting started today, C++ 20, 4 years later with modules. Finally, we can use it because it's in all compilers.
It's in the compilers. Can you use it? I don't hear a lot of success stories about that. And I hear a couple of companies who tried and said, no, we stopped. And then there are a little bit of homework not being done. So I think it's an absolute nightmare that we didn't agree on a common suffix for module files. And so sometimes it's these little pieces, because programmers, you have to lower the barrier for new features. You make it as low as possible. So people want to try out, and it should just work smoothly, at least your first examples. But not having a standard suffix means that you have not an easy way to try out just a little module in your code, converting some code with header file and CPP file into a module and see how it does. And things like that drive me crazy, because we could agree on that. It's just that, some people don't like to agree with others if that changes their own opinion. We are human beings, also in the C++ Standard Committee, and that's normal. But when then the same people complain about, I don't understand why people have a problem with modules, then I can say, I can tell you why. It has to be as easy as possible to deal with that. And a common suffix is so easy to decide on. It's just that I have a problem when Microsoft says IXX is the obvious common suffix. IXX? Why? What does that have to do with C++? Microsoft has a great convention saying we just added new letter, like C++ is this established common suffix. Let's add an M for C++ module. That's the approach of Clang. And GCC doesn't care. They take everything. But we should just agree on CPPM as a common suffix for modules. And so I can just say, here's a little example, try out with the different compilers, and you don't need some magic compiler settings to say this. Yeah, the suffix is different, but it's still a module file, which is possible, of course. But it also makes things clumsy and weird and so on. Homework is not done right. So even if we decide something great, we don't do the homework. And homework means make it easy that programmers use and like your code. And that's finally the same with views.
Right.
Make it easy to use filters, but we didn't.
True. Isn't the suffix like a compiler thing? Is it tool-based or is it user-based? Like, I mean, I understand that modules are not compatible with each other when they come from different compilers.
Oh, no, I'm talking about source code suffixes.
Okay, so it's basically like .cpp, we are now using a different... I was not even aware about that you need a different...
Oh, okay. So here's the point. Why do we have different suffixes? The reason is that this helps us to understand what is the content of a file, and it helps us, and that helps us to understand that we see when we go into a file system that we have an idea what's the role of a file. And
Sure.
You always have to deal with that when you, especially in configuration management, has to treat files differently than others. So there's a good reason we have another suffix for header files and for translation units. So one is CPP file, one is HPP or whatsoever, because we don't compile header files, but we have to compile CPP files. The others are included.
I haven't looked into modules that much, so it's like something I'm learning from. You know, that there's a new suffix where you put the code for modules.
There has to be one, but that's the approach GCC takes. It says, no, just use CPP, so on. But this CPP, a module file, is a combination of a header file and a source file.
You get into problems then because the compiler, of course, doesn't know that this is a module file and maybe just...
Well, anyway, a compiler has to double check things. But you get into problems because it's not only compilers, it's a whole tool chain. And it starts with things like, can I find this program? Can I see just, oh yeah, that's a module file, I'll be there. So the moment you have to deal with your tools differently with a file, significantly differently, then it's usually a good idea to have a separate suffix. And CPPM is a good suffix. C++ module is self-explanatory.
Yeah.
For some whatever reason, Microsoft decided to say the suffix is IXX. The X means a plus sign, 45 degrees rotated, because in the past we didn't support plus for file names. Why? Why do we do that? Why do we have a non-self-explaining intuitive suffix? I don't understand that, especially as for Excel files, Microsoft has a great policy to add a fourth character. So, drives me crazy. and it's really important to have it. So because CMake and other codes really now have to deal with that differently.
For cross-platform code, I mean, if you have a module which is, you know, code for both platforms, what are you going to do? I mean,
it's possible to have different suffix. I mean, you can name a C++ file with any suffix you like. You can say just an ordinary main file containing main has a suffix, I don't know, XXX. That's not a problem. It's just that there is no intuitive support by your tools. So then the tools, you have to say something like in GCC or on Visual C++ with some compiler settings to say, hey, don't be confused. That what you get now is a C++ file.
So
it just has suffix XXX. So
does the C++
it just makes things more complicated. It's still possible to do whatever you like.
does the C++ standard define .cpp as a suffix for
No.
C++?
No, it does not. And that's a funny argument in this discussion. It's not the role of a programming language to define suffixes. I'm not sure. I think I agree with that question. I mean, there are good reasons why Python says the suffix is py, usually, at least as a convention. And the history of that is that the language was designed with on a Unix system, and the default first suffix was capital H and capital C. And then on Windows, there's no difference between lowercase and capital case file names. So we couldn't continue with that policy saying you can detect C++ files with a capital C as contrast to C files with a lowercase c. So all the compilers had to, which then established on Windows, had to come up with a different suffix. One of them was the Zordec compiler introducing CXX as a 45 rotated plus. And others came up with CPP, well, that was Microsoft, and CHH, whatsoever. On no, CHH, I think that's nonsense. But anyway, you see what I mean. CC is also an interesting suffix, so double the number of characters. So we never had a clear suffix. And I remember when Boost was founded, I had a longer discussion with Beam & Dawes, the maintainer and founder of Boost, and we discussed what should be the suffix of Boost files. So should we follow the convention, for example, that a lot of projects still use .h, although it's very confusing to do that, or should we switch to HPP, or should we follow another convention? And we decided that in Boost, header files should be HPP and source files should be CPP. So that came, maybe because of that, a de facto convention, which to some extent was Microsoft wins. And some took it personally. And they said, no, we don't like that. And so, most of the time CPP, HPP is used, but not everywhere. We all know that. And that's okay.
I mean,
but I still don't like it.
Usually you add a class to a project, right? And then the default is in a lot of IDEs still .h, what you automatically get created. And I kind of hate that too, but that's what you have.
Yeah,
and
it's
that's because it's just a minor detail.
Yeah, but the worst decision was made with standard header files, because we could not agree on a standard suffix. It was we could not agree. We agreed we have none. And that is the reason why a header file like vector is not called vector.hpp. And we thought, yeah, well, every tool will then append the suffix. But that did never happen. It turned out that then the file was stored without a suffix. So the header file is called vector. What has the effect that it looks like a directory name, and it looks like, if you try to find header files by suffix in a file system, it's not possible to do so, at least not for the standard headers. So you see how crazy this decision was, just we could not agree on one. And I thought, 30 years later, we have the same problem. Hi, doesn't anybody here learn something from the past? No. And that is why
I do remember the time when
I laughed about it and cry.
And basically people were like, no, you can't include anymore like vector.h. You need to use vector now, just without a suffix for standard headers.
I don't know how we did before we then used the decision. I don't remember that. But yeah,
I
mean,
remember
Microsoft 98 had this discussion.
Windows 6, which
Okay.
I think still partly used that. But I remember like when I started my career, that was like the break, or like still like having code around or examples around, especially where you could see how to use a standard, and then people were pointing out, no, not that header. You gotta remove that .h.
Yeah. So how can you solve that problem? Come up with a standard suffix. Great. Done. We no longer discuss 30 years later about that topic. And still we didn't take the opportunity with module files.
So C++ 23 brings a modularized standard. What suffix does it have?
Say it again.
One of the big features, in my opinion, with C++ 23 is that the standard library got modularized. There's now a module that you can include for the standard.
Then you know more than me.
Or something.
We have in C++ 23 one module for the whole C++ standard.
Yeah.
So with import std, you can do that. I would not say that the C++ standard is now modularized. So in a way that you can have different modules caring about different topics, like one caring about ranges, one caring about concepts.
One big module.
So,
but you get the whole namespace. I mean, that's also always has always been a one namespace. So.
Is it? Well, std, yes, but there are a couple of times we have intermediate suffixes, and now we have the interesting situation that std ranges come up with improved std stuff, like std ranges sort. It's a new and better sort, std sort. Std ranges begin and std ranges size is a new helper function that is better than std begin, std size, which creates a couple of trouble, because you have to teach that to programmers, use the longer path. And the other thing is IDEs might propose both. And guess what? If somebody asks, oh, I have to call begin, a begin freestanding begin function, helper function, and you're getting proposed std begin and std ranges begin, which one would you need and use? And yeah, you should use std ranges begin. It's a better one because it's a fix. But we could not fix or didn't want to fix std begin. And yeah, did I already say the entropy grows in C++? Yes, it does. Good. My time is limited in my rest of the life, so I will not see the end. That's good.
I see we already crossed the 40 minutes. It was nice to talk to you, Nico. I'm looking forward to see you in Berlin.
Yeah, and me too.
Then see you in Berlin, and thank you for your time.
Thank you very much, Jens. It was a pleasure. And as usual, I will probably get some feedback where people hate me. Let's see. It's all. Let me say that once. I complain because I care. That's important. And I would really love that more and more people care. And they also give us a feedback to say, yeah, we want to have it simple, because that's what I see. And the problem is a little bit that the standard is standardized by experts who don't see the problems of ordinary programmers. And that should improve. We can only improve that by forcing programmers give us feedback about what you like in the standard and whatnot, and what we want to have changed. Thank you.